And it's with great pleasure that I introduce Pamela Sankar, who will present on ethics considerations in sharing genome data. She is at University of Pennsylvania. Her bio is in the folder. So please welcome Pamela.
All right. Well, thank you. You're still eating, so that's good. Enjoy yourselves while I talk, and maybe we can have a conversation when we're finished. I'll try to get through this relatively quickly. So I am going to go through, I think the beginning material here is some material that people here are probably very familiar with, but it sets the context that I find important, and sort of talking about how what's going on now in genomics has changed and challenged a lot of the fundamental assumptions in research ethics, and then talk specifically about some research about specific communities or populations of people and how they are responding to the opportunities to participate in open access research in particular. All right, so let's get going then. Traditional genetic research, which of course still goes on, hypothesis-driven, time-limited, and emerged out of, along with, very amenable to standard, what we call now specific consent. In the old days, it was just called informed consent because there was nothing to contrast it to, but now it's specific consent. And so the standard features is that it was for a single study, specific research topic, defined start and end date, strong protections of study-related information, upheld by individual institutions, monitored on a project-by-project basis. Security was safeguarded by anonymization, de-identification of data security, and protective laws. Forgive me, I always have to drink. Sorry. So that's the standard, still goes on. Still the standard for most of the research that goes on, not just in genetics, but across the board in biomedical work. Obviously, that's changing. But it's a very bricks and mortar concept of research and of consent. There's a patient who walks in the door, subject walks in the door, gets a consent, and it's very bracketed. It's easy for it to fit the requirements because it emerged at the same time as the requirements for informed consent emerged. So what happens with next generation sequencing? People here know this far better than I do, but obviously the costs dramatically decrease. Whole genome, whole exome sequencing becomes possible. Flood of personal genomic data. This launches the genomics big data feedback loop. There's big data all over the place, but in genomics in particular, the decreasing sequencing costs plays an incredibly important role here. It's easier to collect data, encourages new questions and new approaches, which in turn demands more data, makes data sharing desirable and possible. Now, of course, at the NIH, they have a long-standing tradition of supporting data sharing, but that's not true across medical research, and sometimes trying to implement that policy has been difficult over the years. But more and more, it's becoming obvious that to do the kind of research people want, it's no longer a gesture or an ethical statement that to advance science, we should share our data. It's turning out that if you really want to do what you're planning to do, you have to share your data. So facilitates and strengthens research, promotes transparency, increases return on investment. So it sounds like a very good concept, and it is. Of course, it's a good concept, but I think that what's important is to understand how different this is from traditional research and how much this is a moving target. And the people sitting in this room, you know, in 30 years, people are going to come and interview you about the history of this. So keep good notes. So do we understand what this means? It's the informatization of medical research, creates great new potential. It changes substantially what the human subject is. I don't know that this is true. I mean, this is not true in all research, obviously, but it certainly is true in the kind of research domain that people here are working in. As I said before, it's no longer a bricks and mortar. It's no longer a specific person who is enrolled for some, either they don't have a disease or they do have a disease, very specific to them. It's more that they want, researchers want the data. They want the information. Yes, they might still seek certain kinds of people, but no matter who you enroll, they will be salient to some kind of a research topic. So it sort of pulls the specific question away from getting patients. So at Penn, there's a phrase, which I'm trying to remember, but basically it's a phrase that says, every patient who walks in the door is our subject, which was a little controversial when they first said it. One phrase, one way of thinking about this is that human subjects research is no longer done with human subjects, it's done through human subjects, which doesn't mean it doesn't benefit them, but it's a very different model, okay? So it's very hard to apply those old bricks and mortar, one topic, one researcher kind of paradigm, where they walk in the door and the protocol, the nurse greets them and explains things to them. It's no longer time or place specific. It means it's very hard to withdraw from what exactly are you withdrawing. It's very hard for subjects to monitor what's going on with the research. And confidentiality is very hard to protect. Now, in the old days, people believed that de-identifying the data in different ways sufficed to protect individuals so that they could not be re-identified in a database. And of course, as soon as you say something like that, that sets a challenge out to just people like you sitting in this room, like, we are going to break this. And one by one, they've managed to do that over the course of 2004, 2008, 2013. I'm sure most of you are familiar with these data breaching research projects. And most recently, and most importantly, the last one proves that it's possible to uniquely identify individuals without first obtaining a reference sample. So this changes the game. Given enough time, resources, and motivation, it seems likely that probably any database could be breached. So what does this mean? What does this mean for human subjects research? What does it mean when this idea of confidentiality was so paramount in all of the previous research ethics writings? Whether it was as important, I can't say nobody ever looked at it, I looked at it, but it was a given that you would protect people's confidentiality. That was just a given. All right, so it's not clear that you can promise that anymore. So the question is, what are the strategies that people have tried to implement, come up with to allow the research to go forward, but do it in such a way that subjects have some kind of protection? So one response, this list is a set of responses of things that the NIH did in response to those articles that I listed on the previous slide. So each time a researcher managed to breach a certain database in a certain way, the NIH implemented new kinds of controls. Controlled access database requiring approval from a data access committee, or they restricted access to aggregated elements, for instance, in dbGaP. Most recently, they removed age, date of birth, from the 1,000 genome database to limit the kinds of work that they did in order to make those most recent identifications. And while this has worked, it is a question of diminishing returns. I mean, given that people will constantly try to breach the database protections, if you rely on implementing controls that are across whole databases or across whole groups of users, you eventually probably start to limit the utility of the data. There is some research, which I couldn't actually get a reference to, but I've heard it mentioned, that says that researchers use limited access, the more restricted the database, the less use it gets. So I actually like to see how they prove that. I'm not challenging it, but it'd be hard to prove, I think. Anyway, all right, so you could limit access. Another way of going on would be to innovate informed consent. So as I said, there used to be informed consent. Now there's specific informed consent. Broad tiered dynamic. So broad is what everybody in certain settings wants. And that's ask research participants to agree to participate in any future unspecified research. Tiered consent gives participants options to select how they want to participate. Dynamic consent allows participants to alter their preferences over time. And I imagine that a lot of you are coming up with even more terms than this. I haven't even begun to understand what you're trying to pull there, but that's okay. I've only been doing this for 20 years, and it's fascinating to me. And actually, I should say, I thank you for the opportunity to make me read this literature again, because it is fascinating how it's changed so dramatically in the last 5 years. All right, so one question that comes up when people talk about these new kinds of consent is, I mean, you could pick any number of concepts, but one of them is open access. What happens when something new comes up is it emerges out of the scientific community. And the scientific community, of course, has spent years arguing over, what does utility mean? What does anonymize mean? What does de-identify mean? And then it gets plunked into a consent form. And somehow it has to be explained in such a way that the subject understands it. And not only are many people not educated in the same way, but also they haven't had the opportunity of that conversation of sort of, why did you define it this way and not that way? And what domain are you trying to cover and what domain are you trying not to cover? And so having been, the first consent forms I worked on in this field were for BRCA1 testing in 1995. And so there has always been an issue. So this is not new to what's going on now, is what I'm trying to say. It's always been difficult to make this transition from concepts that have been in the scientific domain and pulling them out and trying to implement them into informed consent. So most recently, open access has been a particular concern because of the kinds of changes that are going on in genomic data sharing. And there's a study from 2013 out of the Baylor group where they did a randomized trial and they enrolled 323 participants in genomic research with large-scale data sharing and asked if they would agree to share their data. And 53% said yes, but 54% of those 53%, when asked, either couldn't recall with whom they had agreed to share the data or didn't understand that agreeing to open access data sharing meant their data could be accessed and used without restriction. So I only bring that up because, this is a long project, getting the concepts and the methods and the modes in place so that this can proceed in the way that people want. It's going to be a lot of effort and a lot of, which I think happens here a lot, it's a lot of transdisciplinary research where teams are working together with very different kinds of expertise, and that's the kind of group that can get at some of these knotty issues. Another issue that comes up a lot that is, given my background, which is in anthropology and communications and history, is very often I hear in the conversations I have that the subjects don't really care. This is really the institutions, it's the clinics, it's the IRBs. Subjects don't care. And there's certainly research that shows that. There's no question. But I'm going to go over a couple of studies because I think it's very important because that's what you'd like to believe because it would be easier, right? And sometimes it's true. So it's not just that you are going to delude yourself. It's actually sometimes true. So I think what's important when you come across these studies is to be very aware of what to look for in terms of how you want to interpret the findings, okay? And so another article from the Baylor group, this is not the same study as the previous one. They open the article with the statement that their experience and their research and experience show, however, that a considerable number of research participants agree to open access sharing of their genomic data when given the choice. And the reported finding is 194 participants were offered the choice, 63% agreed. That's a good finding. You're more than halfway there. That's very good. But then when you read down, you get the statement that the participants, however, were primarily quite ill, some with terminal disease. They were very trusting of their physicians. They were highly motivated to participate in research. So you need to be very careful about who is it that wants to participate. And one of the things I'm going to follow up on in the next group is there's a time dimension here that's very important. So people are not the same across all populations. It's not just when you think about making consent specific, it's important, obviously, to make it specific to what the genetic data is like, what the protections are like given what the genetic data is like and what the research is like. But it's also very important to look at who the people are who are potentially enrolling. So here you have a group that seems, given who they are, it makes a lot of sense that they are very open with wanting to share their data. Okay. Here's another study, recent study, and what this group did, they were also part of a larger team, a larger project where they were actually enrolling patients. And what they did was they interviewed people that were enrolling, and for this analysis, they divided them into people who were adults and talking about donating or participating for themselves as adults, and people who were parents and talking about participating and donating vis-a-vis their child, not their own participation. And I think, the numbers, it's a little dicey as to how significant these things are, but I think that there's still an interesting trend here. So asked what is the most important, advancing research or protecting privacy, the adult enrolling for him or herself says that 73% say that advancing research is the most important. Only 27% say protecting privacy. Now, the same relationship holds true when the parents are talking about their children, but those numbers shift, right? So it's 60%, so it drops. And it's 40% who say, 60% say, I'd like to advance research, 40% say, I want to protect privacy. So again, an important trend. And then down below, the next part is the next set of questions. Most concerned about when sharing genetic information, and then they can choose what they're most concerned about. And what the parents chose was they wouldn't know what would happen with but it's really the child's genetic information in the future. Whereas what the adults chose as most concerning was having their identity revealed. So again, what I think is important here is it's the time element, all right? So the parent is thinking about 20, 30 years, the future, who knows what's going to happen in society with their child, what's important, what's not important, it's not clear. And so this group, the parents talking about their children, would probably be less excited about the idea of open access. Terminally ill patients who are in a long-standing relationship with a physician, they are interested. So that's, I think, very important in thinking about these things and thinking about the statement, oh, the subjects want to participate and it's just the IRB or the institutions that won't let them. All right, and then I came across this, which I thought was, I didn't expect to find this, but I was trying to find another study, and this was not exactly what I wanted, but I do think it's very interesting. An article that just came out, and the genomics genetics expert survey is only one part of that article. But what they did is they surveyed experts, genomics and genetics experts, including molecular biology professors, bioinformaticians, physicians, genomics, and genetics researchers. And they asked them, among other things, these 8 statements. Did they believe or not? Did they agree or not agree with these 8 statements? And one of the statements was, advantages of genomic-based healthcare justify the harm that genome privacy breach can cause. So do you think, you people who are working on genomic and genetic research and asking people to give their DNA and their information to you, do you think that the healthcare that might put in place justifies the harm that could result? And only 28% thought that it would. So I'm not sure where to go with that, but I think that's an interesting, that's fewer than either of the other groups. So do they know more? Is that the problem? Or I don't know. Okay. All right. So the third way that people have tried to think through this issue of how to have data sharing, genomic data sharing going forward while still respecting patient autonomy and confidentiality is ways of reconceptualizing risk. And this takes us back to looking again at the data breach research that I listed, which happened. They absolutely succeeded in what they were doing, and people have replicated what they did. But when you read the articles, what's very important to look at is that none of it was easy, okay? They used multiple databases. The most recent one relied on redundantly described populations, such as the Sept Utah Mormon collection, which would give them much more information, right? And the people who did it, sophisticated skills, many hours of labor, apparently many false positives. And so, yes, it happened, and there's no question that because it happened, there should be some kind of a response. We should stop saying that, at least stop saying that that data is de-identified. But it also suggests the possibility of another kind of response. And that is that if you consider calculating the likelihood that the data could be breached against the type of harm or the magnitude of harm. So put in the words of the person whose idea this was, not mine, which was Malin in an article I read 2014, the probability of success weighed against the harm incurred. And again, harping on my point, when you're thinking of working on a calculation like this, it becomes very important not just to think about the harm in a general sense, or to presume what the harm is, or to presume that the harm would be the same across populations, but to make sure that you understand what the salient features are of the population. So adult versus child, for instance, would be an obvious one. All right, I like this concept for several reasons, but primarily it's because it grounds confidentiality concerns in a social context. To actually make something like this work, it requires a detailed, flexible framework, which means you have to understand on the ground what the likelihood of breaches are and what they would mean to people. And it requires, you can't just do it once and forget about it. It requires an ongoing evaluation in parallel, because the capacity to breach is going to change and the meaning of what is breached can change. So you have to keep doing this, it doesn't go away. And I think ultimately that's the way you have to think of this. There isn't going to be a single solution. It's going to be a process, and it's going to be integrated into everything you do. And it's very amenable to tiered or dynamic informed consent. It requires thinking beyond relying on technological solutions, which, again, is important. It's just part of this idea of grounding it in actual social practice. Now, what's a downside to it? It does weaken existing human subjects protection in the sense that it presumes, instead of saying nobody can see this data, it presumes that the analysis done is sophisticated and detailed and precise enough and grounded enough that that the person doing it is able to really predict how the individual who might have their information breached is going to respond. So you're putting them up for this possibility. So you have to think about it. I mean, it's a trade-off. What I think is important when you think about that trade-off is to put that trade-off into a broader picture of genomic data sharing and big data. And this is the last few points I want to make. And I frame this as the idea of a promissory note. So this research paradigm has required an enormous investment. I couldn't get current data. I mean, the last study that really tried to estimate it said that the global funding in genomics in 2009 exceeded $3 billion a year. I'm sure it's much more than that now. I did find an article on pharmacogenomics, which estimated that to develop the guidelines for a single drug capable of cutting drug-related adverse outcomes in half, the guidelines, would cost between $1.5 billion to $6 billion. And it would take 20 years, which was, I think, probably the more distressing one. I have to say, among clinicians who I've worked with, there's a lot of skepticism, not all, but some, a lot of skepticism about what the real clinical benefits are. There hasn't been a lot of actual examples. So the findings of genetic variants related to risk typically confer very low relative risk. And even if you combine a lot of markers, it doesn't really necessarily provide very much clinically meaningful information. And most importantly, until there are econometric models that actually show that this information is going to cut costs, insurers aren't going to pay for it. Okay, so I think it's fair to say that this is a work in progress, that advanced sequencing produced a flood of personal genomic data, but unless the data are processed into meaningful information, the utility of that information remains an open question. You have to, I think some people are doing this, I'm sure, but a lot of additional data will be necessary, epigenetics, microbiome, other environmental data, and that, of course, just the magnitude and the complexity on the measures, the orders, are hard to imagine. Opportunity costs, I think, are something also that a lot of people who are interested in health disparities research get very concerned with, because right now, the common chronic diseases, we have a lot of information now about what we could do with people, and a lot of them are behavioral interventions. Most of them don't work, let's be clear, but there's so much more money going into trying to make this work than trying to make those work. Now, whether they would ever work is an open question, but whether this will ever work is also an open question, and they get far less money. And so there's a sense that there's a lot being asked on trust. So big genomic big data and data sharing have incredible potential. I think most people would agree with that. New paradigm, some people have called it the new scientific revolution. It also demands, and this is fascinating, it demands broader social support than any previous research program. I mean, it is of a different order, entirely of a different order. And that's what I was saying before. It has transformed what is a human subject. And again, in 10 years, there will be new languages and new terms and new frameworks with which to think about these things. But right now, we're sort of still back in the bricks and mortar thing and trying to pull it out. So it demands a lot of support for it to work. We're not going to know if it works for a long time, really. And so what I want to say in closing is that I think in turn it confers, given the novelty of what it's demanding, I think it also confers on researchers a very particular kind of responsibility to repay society. And of course, everybody says that that's what their science is going to do, but we also know that historically it very often doesn't. And it isn't an individual failure, it is a societal failure, but there are a lot of people out there who do not get the benefits of cutting edge medical genomic research. And the only way that that's going to change going forward, or not the only way, but part of the way that that's going to change going forward is if the people who are working on this work take it as part of their mission and part of their mandate to make sure that this research, the benefits of this research really do reach all segments of the population. Thank you.
Than the technical aspects of this morning. So I am sure you have lots of questions, and while Jenny sets up her slides, why don't you ask those questions? Or I'll call people. Yeah. Oh, Dr. Talavera is next.
So, yes, I have a question. Ståle Winterbo here. So it's very interesting talk. Thank you. So how, from a sort of an ethical perspective, would you feel about the likelihood computations that go into this cost-benefit analysis if they are forever destined to be empirical? Say that, for instance, if we talk about cryptography, you usually sort of to trust this, you need to have proof. But if these likelihood estimations are based on somebody's ability to do something empirically while lacking a formal actual proof that this is actually, the likelihood is not larger than this, just based on empirical study. Is that a problem?
Well, depends on what kinds of data you put into the model, right? I mean, what are you going to decide is an important factor in estimating the risk?
Well, I'm not sure about that.
Okay. So what would you put into the model? I mean, how would you make one of these?
Well, I'm not sure it's possible.
Okay. Because?
Well, so particularly in the terms of sort of having an absolute quantification of this risk is very elusive and hasn't been really sort of approvable, bound on this likelihood, hasn't been achieved yet.
Mm-hmm.
And I have a suspicion that it might not actually be possible. The best one can do these days is to come up with a relative increase of such a risk without knowing any baseline.
Mm-hmm.
So,
But
that's
then,
my
in theory,
concern.
I mean, cryptography then would fall prey to probably the same problem.
No, not
Why?
really, because
No.
it's a less of a grayscale question.
Okay.
Because you have either access or you don't. In this sort of a sharing, there are certain inferences you're trying to protect against, while
Mhm.
others not, and that is not as easy to state anything authoritative about.
Okay. Well, that's why we work in transdisciplinary teams, because you get.
So I was just wondering if that would make a difference
no,
for
I mean,
from an ethical perspective.
It really does depend to me on. I guess what I imagine is that there is a way, and I'm only imagining it. I don't know it. That there's a way that what kinds of inferences get made also can be specified as general statements, and that's where the people in the population are allowed to weigh in on it. And that, I guess what I'm saying is that from an ethical perspective, it doesn't have to be a perfect system. So from an ethical perspective, what you would want is the best attempt, and the best attempt based on a very clear set of rules. What is the best attempt? And the other function that I think is important is that it's constantly reassessed and reevaluated. And so I think it's, does it protect most of the people most of the time? Not does it protect all the people all the time?
Thank you.
Yeah, thank you. And I would retract my statement after this question that these are more digestible items. So thanks, Pamela. This is fascinating. I'm with you, and I think that many of the physicians in the room will agree that as opposed to an engineering standpoint, if you were only going to treat people that you knew what they had, I mean, good luck, because you would do much less than what people are doing. So I think this search for precision is in some people's minds more than in other ones. And I agree with you. It's got to be most people for most of the time, as opposed to concentrating on the exceptions, which sometimes we do.
Right.
So thanks, Pamela.